Today we're going to talk about absolute convergence versus conditional convergence. Here we have a series. We have n equals 0 to infinity of negative 1 to the n over 2 to the n. And that's equal to 1 minus 1/2 plus a fourth minus an eighth plus a 16th and so on. And if you add up the terms, this is converging to a value of 2/3. If we rearrange the values, rearrange the terms, then the sum still goes to 2/3. That's absolute convergence. If we have another series, let's say n equals 1 to infinity of negative 1 to the n minus 1 over n, which is the alternating harmonic series, then the terms are 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 and so on, and that will converge to the natural log of 2. If we rearrange the terms, we can make it converge to a different value, like 1 plus 1/3 minus 1/2 plus 1/5 plus 1/7 minus 1/4, and so on. We can this does not converge to the natural log of 2. This one actually converges to the natural log of 2 square root of 2. So we can have series that absolutely converge, and we can have series that only conditionally converge. Here's the theorem. If the series absolute value of a sub n converges, then we say the series also converges. And if the series is absolutely convergent, if the absolute value of a sub n converges. The series is conditionally convergent if the series converges, but the absolute value of a sub n diverges. All right, let's make some sense out of this theorem by doing some examples. Example, determine whether the given alternating series converges or diverges. If it converges, determine whether it is absolutely convergent or just conditionally convergent. So let's take the absolute value of a sub n. We have n equals 1 to infinity. This just becomes 1 over the square root of n if we take the absolute value of a sub n. And this is the same as 1 over n to the 1/2, where p is 1/2, which is less than 1. So this diverges by the p-series test. And so this series does not converge absolutely. It can still converge conditionally, and it can still diverge. Now let's treat this as an alternating series. So the first condition for an alternating series is that it must pass the nth term test. The limit as n approaches infinity of 1 over the square root of n is equal to 0. And then b, we have to ensure that the n plus 1 term is less than the nth term, and that is also true. So this series converges, and now we say conditionally by the alternating series test. Let's look at letter B, and we're going to take the absolute value of a sub n. We have n equals 1 to infinity of 1 over 3 to the n. Now this becomes geometric when you take the absolute value, and so r is equal to 1/3, which is less than 1. So the series converges, we say absolutely by geometric series.